So we're going to be starting a part of calculus that is so incredibly important, and you're going to use it from now to the end of the year, probably next year if you're a senior and you take a college course. Derivatives really are a huge, huge component to calculus. And for the most part, they're not too bad. Some of them get a little tricky, but we're going to try to start basic. So let's first talk about this formula that's in the box up here. Okay, so if you look at this formula right here, this is the definition of a derivative. This is the notation for derivative, that little, we call it a prime. So this is f prime of x. That's saying the derivative of f of x. Okay, now we do have a definition. We're not going to really talk about this too much this year, but what I want you to see is, do you remember when we say f of x, that's just a fancy way of saying y, right? So this is saying a y value, and this is also saying a y value, but they're two different y values because this one is f at some value x plus h. And here, this is f at some value x. So this is one y, and this is a different y. Do you remember there's a formula, y2 minus y1, and that's slope, okay? And then it was over x2 minus x1, right? This really is just finding slope. That's all derivative is. So let me tell you where it's a little bit different. So if you go down, I drew two pictures here. They're beautiful, aren't they? Look at this, okay? Now this is a line, right? Don't you know that the slope of this line is a constant slope? It's a negative slope because it's going down. And what I mean by saying that it's a constant slope, meaning to go from this point to, let's say, this point, I go down and to the right the same amount of distance. As I go from this point here to the next point, I would go down and to the right the same amount of distance. Down to the right, down to the right. So this slope is a constant slope, okay? However, if you look at this picture over here, slope just really means how steep something is, right? So if you think about when you go skiing, you can have steep slopes, you can have little bunny hill slopes if you're somebody like me who doesn't really know how to ski. So this is a very steep slope here. But if you look right here, this would be Miss Carter over here doing her little skiing, okay? It's pretty benign, right? It's not very steep. So the slope of this function is different here on the left than it is here on the right, as opposed to over here when you have a linear function, the slope is always the same. That's where derivative comes in. See, for us to find the slope here, we could just say, well, how much down, how much over, or we could do y2 minus y1 over x2 minus x1. But when we have a function here where the slope isn't the same throughout, that's where definition of the derivative comes in. It will help us find the slope at a particular point. I'm going to repeat that again. So derivative is really just the slope of a function at a particular point. So I'm going to go back over here. At this point right here, let's just say that that's A. The slope there at A would be much steeper than the slope here at B. Okay? So when we're finding the derivative, we are finding the slope of the function here, for example, at point A, or we could be finding the slope of this function here, for example, at point B. Okay? So that's generally what a derivative is the slope of a function at a particular point because the slope isn't constant. Okay, so if you look at number 1 in your packet, and also please make sure that you're taking notes on these problems on the first page there, you can see that we have a polynomial and it's asking you to find the derivative. All right, so what you're going to do is you're going to start by taking the exponent of the first term, which is a 5, and you're going to multiply it by the number that's in front. Okay, so let's start with this. So when we write a derivative, we're going to write it as y prime equals. That's how we would write a derivative. So you're going to take that 5, and what you're going to do is you're going to multiply it by the 4 that's in front, and we're going to write 20 x. And then the last thing that we do is we take this exponent and we reduce it or subtract 1 from that 5. So that's going to become a 4, right? So then the power gets reduced by 1, and that's x to the 4th. All right, now we're going to do the same thing again. So we're going to take the power, the next one, which is a 3. We're going to multiply it by the number in front, which is a -7. That's going to give us -21. X, and then we're going to reduce that 3 power by 1, which is going to become to the 2nd. Okay, now let's look at the third term because we don't have a power there, but remember, if there is no power written next to a variable, we always assume that that's a 1. So we're going to take that 1, we're going to multiply it by the number that's in front, which is a 2, which is going to give us 2. I'm a popular girl, everybody's calling me tonight, right? Okay, and then that technically would become x to the 0 power. Okay, now about this 5. Now I'm going to write it down here at the bottom. That's really 5, and it doesn't really even have a variable, right? So technically, the variable would be x to the 0 because you should know anything to the 0 power is a 1. So then what that means is this 5 times this, which is really 1, gives us 5, which is what you have up here. So I'm going to show this to you once and I'm never going to do it again. But when you want to take the derivative of, oops, I thought that was my pen. When you want to take the derivative of this, then what you do is you do the same thing. So you take the exponent, multiply it by the number in front, which is really 0, isn't it? X, and then we reduce the power, which is a 0, by 1, which would be -1. But if you look at this, anything times 0 is really 0, isn't it? So this is the moral of the story. The moral of the story is anytime you have a constant, when you take its derivative, it becomes 0. So anytime you have a constant, its derivative just becomes 0. So we're not going to even bother writing it. Okay, so now going back up to what I have written then, I'm going to just simplify this a little bit. Y prime equals 20x to the 4th minus 21, it's a minus sign, x squared. Now, again, just like what I said down here, anything to the 0 power is a 1. This is really a 1. So, really, this whole term here is really just 2. Okay? And so then lastly, I would just write plus 2, and there is my derivative. So let me just explain something. So let me just go back again. Anytime you have a derivative of a constant, it disappears, right? Becomes 0. Anytime you have the derivative of a term that has an x, just a regular x, and a number, the derivative will be that number. So in other words, 2x, its derivative is 2. If this was 7x, its derivative would be 7. If this was 9x, its derivative would be 9. So that way you don't have to do this every single time. Okay? All right, so now number 2 is a little bit trickier, but we're going to do the same thing. So I'm going to take the exponent. Oops, I keep thinking that I've got my pen on and I don't. You're going to take this exponent of 1/3 and you're going to multiply it by the 3 in front. Okay, so just remember that 3 times 1/3, and you're doing this without your calculator, is really just 1. X to the, now, let's talk about this for a second, because I am supposed to take this exponent and I'm supposed to reduce it or subtract 1 from it. So technically what I'm doing, and let me write this for you so you can kind of see it, but I won't do this every single time. Technically what I'm doing is I'm doing 1/3, right, which is the original exponent, and I'm taking 1 away from it. I think it's easier if you write it in terms of the denominator of this fraction. So instead of -1, how about -3/3? Because then it's easier to subtract. Because remember, when you subtract fractions, you subtract their numerators, which would give me -2, and you keep the denominator, which would give me 3. Okay, so then I know that this has become to the -2/3 power. All right, let's do it again. So now I'm going to take this 3/2 and I'm going to multiply it by the 6 in front. I'm going to write this down at the bottom. 6, technically over 1, times 3/2. Okay, That's 18 over 2, which is 9. So that's going to give me plus 9x to the, now I've got 3 halves, right? I'm also going to put this down here at the bottom. I have 3 halves as my original exponent, and I want to subtract 1 from it. But I'm going to look at this denominator, and I'm going to say, oh, well, wait, that's a 2. So instead of subtracting 1, let me just write it as 2 over 2. It means the same thing, right? And then when I subtract fractions, subtract the numerator, keep the denominator. So this would be to the 1/2 power. And then we have that plus 8. And remember what I said to you, whenever you have a constant, when you take its derivative, everything just cancels out and becomes 0. So here is your derivative for number 2. All right, now let's go to the next one. So look at, look at number 2. I'm sorry, what I did was I guess I put it on a separate slide a little bit bigger. We can ignore that. All right, so let's go to number 3. I think you'll find this a little bit easier than number 2. So number 3, so look again. I have a constant, derivative is going to be 0. I have a constant over here in number 4, derivative is going to be 0. So y prime equals, and now I'm just going to take this exponent, multiply it by the number in front. Well, the number in front is technically -1. So that's going to become -3x, and then reduce the exponent by 1. Now, just FYI, sometimes instead of seeing it as y prime, you may see it written like this, dy dx equals -3x squared. I want you to just understand that when you see this, like especially when you do delta maths, they like to write it like this. It's the same thing as y prime. Okay, dy dx and y prime are the same exact thing. Sometimes you'll see it written as f prime of x, and it would still be -3x squared. Okay? All right, so let's go to number 4. So number 4, we have y prime equals, I'm going to take that 2, I'm going to multiply it by the 1 that's in front, so that's going to be 2t, technically to the first power now, right? Because I'm reducing that 2 by 1, plus, and then remember what I said about any time you have a constant term multiplied by just a t to the first power. Your derivative for that is just going to be whatever that constant term is, which is 2. Now, I kind of don't like to write it with the t to the first, so I'm just going to write 2t plus 2. And there's your derivative. And again, remember that I could write this if I wanted to as dy dx. All right, so for number 5 and 6, I have 2 things going on here that I do not like. And my advice to you is if you have fractions in the original equation, try to get rid of them. If you have radicals in the original equation, try to get rid of them. So what I mean by that is this. Let's look at this one. So y equals, you guys should remember that I can get rid of a fraction if I just take its denominator and bring it up to the numerator. But do you remember, if I bring this x to the 8th up to the numerator, what happens? And hopefully you remember that that means that we have to negate the exponent. So that x to the -8th is equivalent to 1 over x to the 8th. And the reason why we do this is it really just makes us taking the derivative a lot easier. So then all I'm going to do is I'm going to take this exponent, I'm going to multiply it by that 1 technically that's in front, and that's going to give me y prime equals, prime equals, that's going to be -8x. Now be careful here because we have to subtract 1. Well, we're already at -8 and we're subtracting 1 more. So once again, you got to know your positives and negatives in your head. So that should be to the -9th power. And that is your answer. Now, I also want you to know that sometimes later on when we get into some other things, you're going to see why I'm going to bring this up to you right now, but just as an introduction, don't worry about it for right now. But another way to write this is, if you look at this, the only thing that's being raised to the negative ninth power is the x. Okay, this whole thing would have to be in parentheses for the whole thing to be raised to the negative ninth power, and it's not. So just the x is being raised to the negative ninth power. So kind of like up here, see how I took this positive exponent and I brought it up to the numerator to make it negative? I can take this negative exponent, and what I can do is bring it down to the denominator to make it positive, like that. So this is an equivalent answer. Do you have to do that right now? No, you don't. But I just want you to be aware that these two answers are the same exact thing. And there's reasons why we're going to be discussing that. Okay, you just got to hang on a couple of days. Now also, I want to go back, and I should have done this sooner, but I just remembered it now. Let's think for a second. Remember what I said about what a derivative is. It's the slope at a certain point. And if you look at, it doesn't really matter, you can look at this or you can look at this, that doesn't look like a slope at a particular point, right? When I think of a slope, I think of a number, right? And so this is more like a formula. But what's going to happen, and again, just give it a couple of days, what's going to happen is we will be plugging in a number for x and we will get a numerical value, and that will be the slope at a particular point. Okay, so just hang on for a little bit with that. All right, so let's go to number 6, because remember I said I don't like radicals. So do you remember something called power over root? I hope so. So the power is what this x is being raised to. Well, there isn't a power with it, so remember we associate that with a 1. So another way then to write y would be power over root. Okay, because that's the cube root. Now let's go ahead and take the derivative. So we take that exponent, we multiply it by the number in front, which is just a 1, right? So that's going to become 1/3 x. And then remember here, we are going to subtract 1 from it, but I'm going to write it as 3/3. So it just makes it easier for me to do the mental math in my head. So 1/3 minus 3/3 is negative 2/3. Alrighty? Okay, so that technically is your answer. Now, I'm going to show you something, and again, for the same reason on number 5, it's just an introduction, so just relax a minute here. All right, so I am going to look just at the fact that I have 1/3 here, right? So if I were rewriting that, the 1 would be here and the 3 would be here, correct? The next thing you need to look at is I do have a negative exponent. And remember, negative exponents can become positive if I switch their position. So in other words, this right now is in the numerator. I'm going to put it down here in the denominator. So that's going to give me x to the 2/3 down there, right? Hold on. We're having so much fun. We're going to keep going one more. And then remember, power over root. So the power is 2 and the root is 3. So this answer here is equivalent to that answer there. Okay, so here's my power, power, root, root. And this was the 1/3 from the beginning of the problem. Again, do you need to know this right this very second? No, I just kind of want to familiarize yourself with it because it's coming down the pike. Alrighty, and 7 and 8. These are pretty easy, so let's just get straight to it. Y prime equals, take that 2, put it in front, and reduce it by 1. So that's going to be 2x to the first. I'm not going to write the 1. Remember, if you have a constant, that cancels out when you take its derivative. Okay, so I'm going to take that -7, multiply it by the -3. So that's going to give me positive 21. X. Now remember, you are subtracting 1 from -7, so that would be -8. And you can leave this, but do remember, technically, this is 21 over x to the 8th. Okay, but again, for now, it's absolutely fine. Okay, now with number 8, the only thing I would probably suggest that you do, don't take the derivative as it is right now. You have to simplify this, and it doesn't really take too much to do that, so let's do that. We're going to simplify that by distributing. So that's going to be x cubed plus x, and now take the derivative. Y prime equals 3x squared plus 1. Pretty easy, right? Okay, now remember again, another name for y prime, Delta Math loves it, dy dx. Okay, now sometimes, just sometimes, not for this particular question, they'll ask for y double prime. Want to take a guess what y double prime is in relationship to y prime? Its derivative. It's called the second derivative. This is the first derivative. This is the second derivative. So basically, it's taking the derivative of the derivative. Okay, not hard to do. So we write that as 6x, right? Because we would just take this 2, multiply it by the 3 in front, okay, and reduce by 1. And then remember, any constant's derivative just is 0. So that would be your second derivative. Now, FYI, you'll see it coming down the pike. Sometimes they will write it like this. Okay, so when you see the little 2's with the dy's and the dx's, that means second derivative. If you saw 4's, that would be the fourth derivative. Don't worry, we're not doing that, but just so you get the general idea.